Hello everyone, my name is Krishna Agarwal. Today I'm going to present my AAT Tech Talk of Human Computer Interaction, and my topic is Analysis and Implementation of Message Authentication Code, that is MAC, algorithm for GOOSE message security. So, in the realm of power system, cybersecurity threats are becoming increasingly prevalent, posing significant challenges to integrity and reliability of critical infrastructure. So, message authentication code algorithm plays a crucial role in safeguarding communication, integrating by ensuring that messages have not been tampered with or modified during transmission. So there is a growing awareness towards cybersecurity threats in power system. So that is ease of connection via Ethernet instead of traditional hardwired system, and standardized message structures with ensure interpolarity and unwanted consequence of these increased vulnerability to cyber attacks. It is easier to access Ethernet based networks, and standardized messages allow hackers to know exactly what instructions to give, and also publish to complement by adding security features. So ICE identifies that authenticity is an important security requirement for communication in SAS, that is substation automation system. For achieving this, we need a standard recommends the use of authentication value algorithm with digital signatures. So for digital signature, use of different algorithms as per request for comments is stipulated. That is found that algorithms based DS require computational time on order to millisecond, which is not suitable for generic object oriented substation events. That is GOOSE, message based application. So what is GOOSE message? Generic object-oriented substation event message are a type of data exchange protocol used in substation automation systems. They transmit critical information about substation events such as breaker operations, relay status, and analog measurements. So, importance of MAC algorithm. The main objective of GOOSE message is to offer a fast and reliable mechanism to exchange of data among substations. GOOSE messages are directly mapped to Ethernet layer to avoid the network and transport layer headers, reducing the overall size of message. This in turn reduces the propagation and processing delays of the GOOSE messages. So GOOSE message consists of destination and source address field, that is 6 bytes each, followed by an ether type field of 2 bytes, which defines the type of GOOSE message. GOOSE PDUs consist of APID, length, reversed, and the different fields. Implementation of message authentication code algorithms require addition of a MAC value to Goose message. Goose message structure is very well defined by IEC, and the modification required for security extension is defined by IEC. Accordingly, MAC value is appended to the extended Goose frame formatting extension field. So as this increase the length of the Goose frame, the difference is reflected on the second byte of the second byte reversed field. So as we have seen that MAC algorithms protect Goose message from unauthorized modification, ensures that data received is authentic and has not been altered. So this safeguards the reliability and trustworthiness of substations operations, preventing potential disruptions or malfunctions. Challenges in cybersecurity. Cybersecurity threats. Systems and increasingly interconnected and rely on electronic communication, making them vulnerable to cyber attacks. As we can see, almost all the activities are directly or indirectly related to power systems, interconnected, increasingly power systems, and also rely on electronic communication. So cyber attacks are more easier, or you can say vulnerable. So these attacks can target Goose messages, aiming to manipulate data, disrupt operations, or compromise critical infrastructure. So we'll discuss about the innovative MAC solution, that is message authentication code. In this we have different authentications. First is secure Goose generation. So they have developed a GOOSE and SV generator library to run tests on custom messages by integrating MAC algorithms. Proposed a new library which is also developed for MAC, that is message authentication, and also it secures GOOSE messages communication by employing key verification and MAC algorithm. It is written in C language utilizing Linux structures. This is also called as extension field of GOOSE. The secure GOOSE message generation algorithm can be very useful. Next is tamper detection. Any change in GOOSE PDU during transmission reflects a discrepancy between the appended MAC value and the one recomputed at the receiver. This shows a result generated by the algorithm framework developed in the letter. That means HMAC and AES-GMAC, that is hash-based message authentication code, and advanced encryption standard Galos's message authentication code are two prominent MAC algorithms used for Goose message security. These algorithms provide robust authentication and integrity protection, ensuring that authenticity and trustworthiness of data. Enhancing data integrity. Protecting critical infrastructure, first of all, that is implementing MAC algorithms for Goose message enhances data integrity and protects critical infrastructure from cyber attacks. This is the first benefit as a data integrity, and this safeguards the reliability and stability of power system, preventing disruptions and ensuring continuous operations. Securing critical infrastructure. Critical infrastructure is the physical and virtual assets that are so vital to the day-to-day functioning of a society that their disruption or destruction would have a demonstrating impact on security, national economic security, national public health or safety, or any combination of these three. So this is what the importance. Deployment consideration, we have practical considerations. That means when deploying MAC algorithms for Goose messages, factors such as computational efficiency, performance requirements, and interpolability need to be considered, and careful selection of the algorithm need to be done. Next, evolving security landscapes, adopting cyber threats. Cybersecurity landscape is constantly evolving with new threats and vulnerabilities emerging regularly. So continuous evaluation and adoption in MAC algorithms is required. So what are the future trends? Advanced security mechanisms, such as research and developments are focused on exploring advanced security mechanisms like cryptography signatures and key management techniques and all. These advancements will contribute to more robust and resilient cybersecurity posture. Empowering cyber resilience. That is cornerstone of critical infrastructure protection, and MAC algorithms play vital role in securing these boost messages. Conclusion. MAC algorithms such as the hashing MAC algorithm and the GMAC algorithms provide robust as well as safeguard the critical infrastructure of cybersecurity. Thank you.